Hi everybody, this is Bharat, Assistant Professor, Department of EEE, SS College of Technology, Coimbatore. In the previous lecture series videos, we have been discussing about the various topics for the course measurement and instrumentation. In today, we are going to discuss about the standards and calibration topic in the course measurement and instrumentation. Before getting into the topic, we have a small recap about our previous session. What are the various types of errors in measurement we have seen in the last video, like systematic errors, random errors, and the gross errors? In today, we are going to discuss about what are standards and what are calibrations. As we all know, standards is defined as internationally recognized measurement units. For example, a meter, a kilogram, all these are internationally recognized standards for length. Calibration. What is calibration? Measuring process comparing to a standard value. That is, as per the definition, the process of comparing measuring instrument to a reference standard to determine deviation and make adjustment. That is called calibration. What is the importance? Ensuring accuracy, regularity compliance, safety assurance, quality control, and international trade. These are the various standards and calibrations used for this. What are the various types of standards? The standards are classified basically into international standards, primary standards, secondary standards, and working standards. You could see the highest of all is the SI units. Then we have the primary standards, secondary standards, working standards, and the process instruments. What are international standards? BIPM maintains the international agreement. International standard gives the exact value of a measured quantity. From that value referred to a primary value is taken by each countries and each labs in the countries. A national level standard is called as the primary standard. Ultimate reference is taken from this international bodies. We maintain a national standard, and for the other places in the nation, we take the reference from the primary standards. Secondary standard is the basic reference industry maintained, checked against the reference standards. Working standards is what we use in the lab, in day-to-day activities and all those things for calibrate general purpose instruments and quality control. All these comes under the working standards. So 4:1 accuracy ratio is to be maintained. That is, calibration standard should be 4 times more accurate than the instrument being calibrated. What are different standarding organizations like ISO, as we all know, International Organization for Standardization, IEC, Electrotechnical Commission, NIST, where is it? Both are international. In national is National Institute of Standard and Technology. BIS, we all know, Board of Indian Standards, Bureau of Indian Standards. What is the need for calibration? The comparing the measured device against a reference value. What is the purpose? It determines the deviations. It ensures the accuracy. It makes adjustment wherever required. When there is a change or an error occurs, the calibration recreates or minimizes that error. How are the methods used for calibration? One is called direct comparison, simultaneous measurement between the next, substitution, standard replaces instrument, measurement errors, that is this transfer standards. This is also done in the 4:1 accuracy ratio. Standard should be 4 times more accurate than the instrument. We can see the calibration hierarchy on the right-hand side of the screen. So during the calibration process, you can identify the equipment. The calibration process flow is shown in the diagram here. Identify the equipment, critical or non-critical, determine the calibration level of the equipment. Next, passing to the calibration organization staff. Qualified staff should handle the normal calibration process. Decide the deadline time, typically annually or basically how we are going to decide. Perform the calibration and record the results. Analyze the results. So this is the various stage for calibration. Next comes the traceability. Trace means measurement to standard through unbroken chains to SI units. Trace has several benefits. It ensures the accuracy, document path, accounts for uncertainty, and international trust. Calibration intervals like typically annually for equipments, 2 years if it is stable or consistent, triggers before and after. This can be explained with a case study. NIR instrument for a fluid dairy products, frequent calibration of 2 weeks essential. Irregular calibration compromises the precision, significant revenue losses may occur. Analyze, we check accuracy, precision across US dairy product has been done. Compared with the calibration frequency measured, butter fat content is higher, reference taken from the analysis. So frequent for calibration is required for all these types of cases. Result, clear pattern identified. Regular calibration improves the reliability, direct correlation with performance. Consistent calibration is crucial for revenue growth and operational efficiency in all dairy products. As a summary, we have seen different types of standards, calibrations, and traceability. With this video, I'll conclude the different types of standards and calibrations used for measurement. We will meet you again in the next video. Thank you.